first intro video for AP Chemistry. Today I'm going to be going over this thing I like to call moleville. So this is just a handy-dandy map kind of sort of thing to help you through problem solving to figure out how to get from one unit to another. So in chemistry we do a lot of unit conversions because we measure one way in a lab with things that you're actually touching and feeling, so it's got to be at our size scale, but then you need to talk about it in terms of atoms and molecules and fermion units and how they're interacting. So before I do this, I want to talk about something that you kind of know. So let's assume x equals y. If we know this, then we can say that if we have x over y, that's the same thing as 1, which is the same thing as y over x. So if I take any a and multiply it by x over y, it technically stays a, because anything times 1 is still itself. So we're going to use this concept and apply it to something called dimensional analysis. And this is when we use unit converters, which are fractions that are equal to 1, to change the unit of our measurement into a different type of unit that we want to work with. So what moleville is kind of a map that all relates to moles. Now moles is this handy-dandy unit that we use in chemistry that really is the center of our chemistry world. What is a mole? So 1 mole means it's a group of 6.02 times 10 to the 23rd representative particles. So these two things are set equal. Since these two things are set equal, I can make fractions out of them, these guys, that are technically equal to 1. I can have 1 mole over 6.02 times 10 to the 23rd particles, or I could have 6.02 times 10 to the 23rd particles over 1 mole. And both of those are technically equal to 1, and you'll see in some calculations how I can use that. Well, what is a representative particle? It's just the things that make up your sample. So the types of representative particles are atoms. So for example, if your sample was made up of sodium, then it's just made up of sodium atoms. It could be made up of molecules. So for example, if you had a sample of CO2, carbon dioxide, that's made up of molecules. Or it could be made of formula units. Formula units is a term that's often misused. It's skipped. Sometimes people will call something a molecule when it's really a formula unit. So for example, calcium chloride doesn't have any molecules in it because it's ionic. So this is ionic. We'll go over bonding in a later unit in more detail if you don't remember from your Chem 1 course, but basically if it starts with a metal, then it's going to be an ionic compound. The reason that it's not a molecule has covalent bonds. They're actually linked together, so the electrons are interacting that way. Formula units are just held together by Coulombic interactions, and there is generally a crystalline structure. This is just the lowest ratio of them. There's not an actual, generally, boom, this is a singular formula unit. It's a whole network of it, but we'll get to that in a later unit. Okay, so if you have moles and you need to get to representative particles, here is the things that are equivalent that you can make into fractions to use. But we don't measure atoms in the lab. We really don't measure moles. The main thing that we measure is mass. Mass, which is measured in grams, mass can be converted to moles, and we use the molar mass is equal to 1 mole. We will go over molar mass in Unit 1. You're going to use your periodic table for this. Just a little need the periodic table to calculate the molar mass. Another way we can get from something measured in the lab to moles is we can use volume. Volume is how much space something takes up. It's a three-dimensional unit. And we typically think of volume as in liters. By the way, grams is G for this. So our measurement is a little bit, there's a couple ways to get here. So 22.4 liters is equal to 1 mole, but it has to be a gas at STP, which is standard temperature and pressure only. So if you're talking about a solid or a liquid or a gas that's not at standard temperature pressure, you can't use this conversion. This conversion only works for a gas at standard temperature and pressure. The other way you could get from moles to volume is you could use this thing called molarity. Molarity is set up in moles per liter. So you'll have to figure out which way you want to use molarity, whether you're multiplying or dividing, and we're going to get to molarity in a later unit as well. There is another way you can move around here. You can actually get directly from mass to volume by using the density. So for this, you want to be mindful of units. For example, a density might be in grams per milliliter. So you could be getting out of grams, but then you're going to milliliters. So then you would have to convert to liters if you want to use liters here. It could be kilograms per liter, and then you would have to convert to grams. So just be mindful of that conversion, and we'll go over how to do these within the next set of intro notes in the dimensional analysis ones. I also want to point out that a milliliter is equal to a cubic centimeter. Alright, you also might need to change your substance. So you can, there are two ways to change the substance. So these are the only ways you can change what the substance is. You can either do it in moles, and you can do a mole to mole ratio, and this comes from your chemical equation. So this is the only time, one of the two ways you can change your substance. Or you can change your substance here with an atoms to compound ratio. So overall, here's the chart. It's a little bit bigger than that. And I will make a video with a couple practice